Question number 18 is to solve problems based on arc length. Let us look into the arc length formula. Here we have a simple formula that is integral from the limits a to b. Square root of 1 plus this is derivative f prime of x or f dash of x. That's the derivative squared dx. So the derivative is to be known and then it is inside the integral and you solve it up using the formula. Let's solve a problem here. You can see they have told a cable is hung and they have given hyperbolic that is generally used in mechanical engineering to exactly solve the detailed force, motion and everything. But for us now they have also given it in simple terms, that is exponential only. And they have mentioned the cable is 20 feet apart. Okay, that's fine from here to here. But we don't want that length. We want the arc length. They have told the limits are from -10 till +10. Okay, this is helpful and the equation is given for this particular cable. Now, the reason for doing this particular example problem is the same problem is used in one of the other exercise problem as well. Now, what you need to do first is derive this function. How would you derive it? Derivation is y prime, that is phi is a constant, let it be. What is the derivative of e to the power x? I'll write a bracket over here. E to the power x is same, so e to the power x by 10 itself. But here, if it was e to the power x, the derivative is e to the power x, that's it. But if you have e to the power 2x, the derivative is e to the power 2x, then the chain rule applies. 2x is derivative 2. So the same thing must be done. Now here instead of e to the power x, we have x by 10. So it will be e to the power x by 10 multiplied by 1 by 10. Why is this? Because derivative of x is 1 and this is constant. So we will have 1 by 10 plus. Now what happens here is same thing, e to the power minus x by 10. But do you remember the derivative of e to the power minus x? It is minus e to the power minus x. Now what happens when we have e to the power minus x by 10? It's going to be minus e to the power minus x by 10 multiplied by 1 by 10. So here, or you can just derive this and get minus 1 by 10. Now why we write minus? Because the derivative of this minus x would be minus 1. So that sign is over here. This is the actual thing, but I have written over here in bracket. This is also fine. Whichever you understand properly, it's more than enough. Now we will have to simplify that. So let me just clear that off. Here it'll be phi constant itself, but I can see this 1 by 10, 1 by 10 is common. So I'll take this out. It'll be phi into 1 by 10 or phi by 10. Here it's going to be e to the power x by 10 and then we have this minus sign over here, minus e to the power minus x by 10. So this is the answer. You can simplify this 1 time, 2 times, so it'll be half and this term. So what we have over here is the derivative f dash of x or f prime of x. Now derivative is done. Now what is the formula? Integral a to b. Then we have square root 1 plus f prime of x dx. Now what is the interval over here? It's minus 10 to positive 10 and we have 1 plus f dash of x, this entire thing, just write it out. And oh, I forgot to square over here. That is very important. Square is required. So it's half into e to the power x by 10 minus e to the power minus x by 10. This, I'll close it and square it up, dx. So this is it. I'll just put it in the calculator now and we can easily solve it up. I'll show you how exactly we are to put the integral symbol. Then we are to put the square root 1 plus, open a bracket over here. You can write half or 0.5 is the same thing, multiply. You're opening another bracket for these two, okay? So shift and natural logarithm function gives you exponential e. That's Euler's number. And then make the fraction symbol, alpha x by 10. And over here, write minus sign, shift e to the power again alpha x by 10. But I forgot to write the negative sign over here. It's minus and close the bracket. Go down now, close the bracket. And we need to close one more bracket and now square it up. And what are the limits? It's from minus 10. The lower limit is always down, the lower value, upper limit. And that should be the answer. It is 23.504. Let's look into the answer. See, you can write it in steps, I've just written everything at once. First, you need to derive this, write the formula, substitute it properly, and then solve it up. Over here, this is the given function, and derive it up. And over here, see, I've done in derivation in detail, so please follow that. Over here, it's directly done. And then using the formula, you just substitute it, and then you get the answer. It's rounded off 23.5 feet. So that's how we solve this problem. Now let's solve some more problems here. Again, it's all the same thing, but over here it's just that the rope is 40 meters and the limits are minus 20 to 20. Then they have given the catenary equation here, that is y is equal to 10 e to the power x by 20, and same thing. So let's directly solve it up. You can write it as y or function of x, f of x is the same thing. 10 into e to the power x by 20 plus e to the power minus x by 20. Now when I derive it, I'm going to do it directly. So I know 10, and this will be 1 by 21. Okay, let me just do it in steps. You can directly solve it by just dividing this by 20 and getting it out, like 1 by 20 can be taken out. But the steps are over here, e to the power x by 20 multiplied by 1 by 20. If you're thinking how this came, the derivative of e to the power x by 20 is over here, and then the chain rule, x by 20 derivative is x is 1 by 20 plus. Now I'll directly write it's minus. Why? Because there's minus over here, so it'll be negative. E to the power minus x by 20 multiplied by 1 by 20. Now that's enough, but you can simplify it. It's better to simplify f dash of x. Over here, what happens is this 1 by 20 and 1 by 20 comes out. So it becomes half again. And we have e to the power x by 20 minus e to the power minus x by 20. That's it. Now let's use the formula. It's square root 1 plus derivative. I'll just write the formula first. The whole square dx over here integral a to b. This is the arc length. And now what are the limits? It's from minus 20 to positive 20, square root of 1 plus your half times e to the power x by 20 minus e to the power minus x by 20, the whole square dx. I hope this is clear. And what do we do here is just put in the calculator and you can solve it up. So I've just typed everything, entire equation in the calculator, integral minus 20 to 20, and over here it's 1. Open the bracket, half times. I've written this equation and close the bracket 2 times before squaring it, because 1 is this bracket and then the outer one for square. And then the dx will already be there, and that's it. And press equal to. That is the answer. You can even try doing this by, formula method, but it's just going to take a long time. Just use the calculator. It saves a lot of time. As long as you have written the derivations properly, the formulas properly, everything substitution properly, it's more than enough. You can try even squaring this up, simplifying it, and then using the calculator. Maybe 1 or 2 steps. Square this will be 1 by 4th, and over here it will be 2x by 20 minus 2x by 20. And this needs to be when you're squaring this is direct, but over here you need to use a minus b the whole squared formula, which is a squared minus 2 times ab plus b squared. So use this formula and then you can simplify as well. So, or directly put in the calculator. Let's look at the answer. Yes, it is 47, nearly 47 feet, or whatever the dimension is. It's meters. Similarly, please do solve the other problems. It's just like that. You can solve it by yourself and then find the answer over here. Check the answers. And the last one over here is interesting. Here they have told in the example 4.4, which we just did a while ago, this figure was there. Compute the sag in the cable, that is the difference between the y values in the middle, that is at x is 0, and at the poles, at x is equal to 2. Given the arc length calculation, surprising. Now, given this, is the arc length calculation surprising? Now, what we need to do is, first let's find the sag. Sag means, see, over here, imagine the cable is tied and tied. It doesn't stay flat. It doesn't stay exactly horizontal. It'll sag because of the weight of the cable and it goes like this, arc length. It sags. This is called sagging. Now, what we need to do is we need to calculate the sag. How would we calculate this? Now, if you remember the equation, see, we need to refer to the 4.4 question. So this was the equation given. We had solved it, we derived this. So to find the sag, let's find x of 0 for this particular equation. Instead of y of x, I'll write f of x. F of 0, what is it? So what was the equation? It was phi e to the power instead of x. Now here the question, over here I'll write 0 plus e to the power minus 0 by 10. Now you just put this in the calculator and you will get the answer. So what is the answer over here? It will be phi, anything to the power 0 is 1, plus over here again minus 0 is neutral, so it's 1. So phi times 1 plus 1 is 2, that's 10. So the answer must be 10, yes. That means this, for this equation, this length is how much? It's 10. So now let's do it at the poles. So we can see it's about 15. So the sag is about 5. But no, it's not 15, it's 15.43. So we need to find it again accurately. So now what we do is f of 10. Same thing, instead of x, I have to just substitute 10. Now here it will be 5 times e to the power 10 by 10 plus e to the power minus 10 by 10. And over here, what's going to happen? It's going to be e to the power 1 plus e to the power minus 1. You just have to put this entire thing, see over here, this in the calculator. And when you solve it, you'll get this answer, 15.43. That means over here it was 10, here it is 15.43. What is the sag here? It's 15.43 minus 10, it's 5.43. That is the sag. So this is how you find the sag, but they have also asked you to estimate the arc length, right? Now we are not doing the derivation. We know this much is 5.43, right? What is this length vertical? So this is, corresponding to 10 because it's told it's a 20-meter cable. At the center it's 0, so this much will be half of 20, it's 10. Now how would you find this arc? We can use Pythagoras theorem to estimate this. We'll just estimate it. So Pythagoras theorem is the hypotenuse, the longest side. This is the hypotenuse C. And if you imagine this is A and B, it's given as C squared equals A squared plus B squared. So in order to find C, you just have to take square root on both the sides. It will be A squared plus B squared. So C will be square root of 10 squared, sorry, it's 5.45, it's the same thing, squared. Here now this is the arc length, but over here it's on the side as well. So whatever answer you get over here, you just multiply it by 2 to get the estimate of arc length. Let's look over here. See, it is basically square root of 10, that's the length over here, and the sag is given as 5.43. Square them both, and why is this 2? Because it's both the sides, right? So you multiply it by 2. The answer is 22.76. If you recall, we had got 23.5 meters using the derivatives. So what we found out over here is very, not accurate, very close enough. That's what you can say. So that's how you solve this problem. That's the end of this problem. I hope this has been helpful. Just remember the formula, derivative is very important and squaring the derivative is important. And then we can just use the formula and solve for the arc length.